Good morning or good afternoon, it's Miss Bauer here, and today we're back to talk about rhombi. Now, rhombi is just the plural form of the word rhombus. And because a rhombus has two pairs of parallel sides, that makes it a parallelogram, which is what we've been talking about. So if we take a look at that formula chart, the key feature of a rhombus is that all the sides are congruent. Now, a rhombus is just a particular form of parallelogram because both pairs of opposite sides are parallel. But what's important to note about a rhombus is that all the sides are congruent. So people like to think of it like a slanted square because all of our sides are congruent. So I'm just making up numbers here, but let's just say that one side is, let's say 5. Well, then all of the sides would be 5. That's how a rhombus works. Now, if we talk about the diagonals in a rhombus, the diagonals in a rhombus happen to intersect at 90 degrees. Now, parallelograms don't do that. If we just look, these pictures are drawn to scale. Like, those wouldn't be 90 degrees. And if we look at this rectangle, we talked about, like, those were 80 and 80, 100. That's not 90 degrees. But in a rhombus, whenever our diagonals intersect, they're going to intersect at 90 degrees. So what we have here in this rhombus is we have all of these right triangles. Now, we had right triangles in a rectangle as well. We did not have right triangles in a parallelogram, but we do have right triangles in a rhombus. Whenever we draw in those diagonals, we have 90 degrees, which creates our right triangles. Now, the key features of the rhombus are the 90 degrees and that all the sides are congruent. And then once they start giving us more information, then we can kind of fill in from there. So just like a parallelogram, this diagonal will cut the other diagonal in half. So that piece should be the same as that piece, and then that piece will be the same as that piece. So if I said that this part right here is 3, well, then I know that this piece over here is 3 because the diagonals cut each other in half. And then because this is a right triangle, I can figure out this missing side right here. If I know two sides, I can do Pythagorean Theorem. And this is where those triples come into place. And that most basic triple is 3, 4, 5. So if I see 3 and 5, well, then this piece would be 4. And then that would make that piece right there 4. So that's about our sides and the diagonals. What's nice about the angles in a rhombus is that it ends up being very symmetrical. So once again, I'm just making up numbers, but if I said that this is 40 degrees, then the other side would be 40 degrees, and then these ones down here would be 40 degrees and 40 degrees. The rectangle didn't do that. The rectangle alternated, so it's like 50, 40, 40, 50, 50, 40, 40, 50. So the rectangle is symmetrical right there, but the rhombus is symmetrical on the diagonal. So I have 40, 40, 40, 40. And then if I want to find this missing one, I have a few options. I can remember that a triangle adds up to 180. So if that's 40 and that's 90, I add and subtract. I'm going to get that this is 50. Or if we remember that this whole corner and this whole corner add up to 180, well, then 40 and 40 is 80. 180 minus 80 is 100. Divided by 2 would be 50 and 50. And then the other side would be 50 and 50 as well. So I just kind of like to remember that a rhombus is like a slanted square. It's 90 degrees in the middle and that all of our sides are congruent. So let's take a look at some of these patterns. Let's take a look at solving some rhombi. Okay, so because a rhombus is a parallelogram, all of these features are still true. The diagonals bisect each other, opposite sides are congruent, opposite angles are congruent, consecutive angles add up to 180. That's that rule we just talked about. But there's some more specific things, and that's that the diagonals are perpendicular, so it's 90 degrees, and they bisect the angles. So that's where that 40, 40 came from. So like my diagonals cut my angles in half. That's what bisect means. So that's where I get like 40, 40, 50, 50, whereas the rectangle alternated. It didn't bisect the angles. So the diagonals are perpendicular and bisect the angles. You can cut out that but blank congruent, but all four sides are congruent. Remember that you'll have access to this other cheat sheet right here, and so like feel free to write on this, and then you can use this throughout this unit. Because there are just so many rules, it can be difficult to remember. So let's take a look at some examples. So if this is a rhombus, I can go ahead and I already know. I'm going to put ticks all the way around. So because it's a rhombus, all my sides are congruent. That's the key feature of a rhombus. And because it's also a rhombus, I know that I could put 90 in the middle. So remember, a rectangle was where I had 90 in the corners, and I couldn't put the same number of ticks on the sides, but the rhombus is ticks all the way around and then 90 in the middle. So just be careful with all these rules. Okay, it tells me that RST, so this whole corner angle up here is 67 degrees. That whole corner is 67. It wants me to find RSW. Well, if we go back to that reference chart, or I go back and I look up here, remember that the diagonals bisect the angles in the corner. So I just need to figure out what's 67 divided by 2, and that's going to tell me what RSW is. That would tell me what half that angle is. And half of 67 would be 33.5 degrees. And that's it. Now there's a lot more that they could ask us. If this is 67, then this angle over here would also be 67. And then if they wanted these other ones, all that I would need to do is do 180 minus 67. And so 180 minus 67 is 113. And then if I wanted to find these particular angles, then I would just do 113 divided by 2. And that's how that rhombus works. So taking a look at this next one, it says find the measure of angle SVT. So this is this angle right here. If the angle of STV is 135 degrees. Okay, now because it's a rhombus, I know that I have 90 in the middle. I know that I could put ticks all the way around. But because it's a parallelogram, I have to remember in a parallelogram that the angles next to each other should add up to 180. So if I find out what 180 minus 135 is, that's going to tell me this whole angle. So go ahead and figure out what's 180 minus 135. And that would make that whole angle 45 degrees. And then to just find each half, remember in a rhombus that it's cut in half in the corners. I'm going to do 45 divided by 2. And then 45 divided by 2 would just be 22.5 degrees. And that's how the rhombus works. That's how those angles work within a rhombus. So taking a look, if the measure of angle SWT is 2x plus 8, find x. Well, we said all these angles in the middle of the rhombus are 90, so if SWT is 2x plus 8, then 2x plus 8 would equal 90, and then I'm just going to solve for x. That's because all of these are 90 right in there. So subtract 8. So then 2x would equal 90 minus 8 would be 82. Divide both sides by 2, and then x would just equal 41. And that's it. Now, we've been talking a lot about the angles. Let's talk about the sides really quickly. In a rhombus, if we know that one side is, I'm just going to make up numbers, let's go 17, then all my sides would be 17. That's how a rhombus works. And then if they gave me some more information, I could use that and use what I know about right triangles to do even more. So let's just say that they told us that this piece right here is 8. Well, if it's a parallelogram and rhombus is a parallelogram, if this piece is 8, then what does that piece have to be? That piece is also 8. And then I could do Pythagorean Theorem to find that missing leg. I could do Pythagorean Theorem to find this piece right here. Okay, now, a squared plus b squared equals c squared. But if you know your triples, then you should be starting to recognize them because they're going to pop up a lot in this unit. So remember our triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And the last number is always going to be the hypotenuse. So right here in this particular problem, if I have 17 and 8, then my missing piece would be 15 and 15. So if I asked you what's this whole piece, that would be 30, and then that whole piece right there would be 16. So if you remember these triples, you will kind of see them pop up again and again and again and again. Worst case, remember you can always do a squared plus b squared equals c squared. But today we are going to focus on the angle rules. So taking a look, it says find the value of x if WRV is 5x plus 5. So if I trace that, WRV is 5x plus 5. And then WRS, so WRS, this other part, is 7x minus 19. Well, remember in a rhombus that the diagonal cuts the corner angles in half, meaning that these two parts are exactly the same. And if they're congruent, if it cut it in half, if it bisects it exactly the same, that would just be part equals part. So all I have to do is 7x minus 1 equals 5x plus 5. And now I'm going to solve for x. So I'm going to go ahead and put the letter on the left by subtracting 5x. So 7x minus 5x would be 2x minus 1 equals 5. And then I'm going to add 1 to both sides. So 2x would equal 6. Divide by 2, x would equal 3. Now, let's say they wanted the actual angle. So if I go and I plug 3 back in, I should get the same thing on both sides. So 7 times 3 is 21. 21 minus 1 is 20. 5 times 3 is 15. 15 plus 5 is 20. So this is 20, that's 20. If I go to the other side, then that would be 20 and that would be 20. I know that all of these are 90. And then I have a few options for finding these last ones. Remember that 20 and 20 is 40. If they're next to each other, they should add up to 180. 180 minus 40 is 140, and then take that and divide it by 2. So then that piece would be 70 and 70, and then it goes across. It's the other way as well. And remember, a triangle adds up to 180, so I could use that trick as well. And that's it for a rhombus, or rhombi for plural. We'll pick up with